We are on the section 3.1, 3.2, and 3.3 on your page 25. We are going to talk about the number line, points, distance, midpoints, and intervals. And we are going to talk about those for the purpose of stats, right? So we need to talk about, what do we try to do? And for the things we are talking about or referred to, is about, say, the frame of a reference. So what kind of things we are talking about? Say, the average weight of a newborn baby's weight, right? Or the average of a bus wait time. And so see how much time, average speaking, you have to wait for the bus line. So these type of things. Then we are going to visualize it, okay? So we visualize it for the frame of reference. We use the number line and points, how long you have to wait, that type of things. So look at your page 25. It says plot, first one, plot points and intervals on the number line. The number line is of fundamental importance, okay? And it's used repeatedly in statistics. It is a tool to visualize all the possible outcomes of a study and to organize the result of the study. Often a diagram is placed above the number line to provide us with a picture of the results. So what are they talking about? Visualize all the possible outcomes of a study. Say we study what's the average of a newborn baby's weight. The baby's weight would be our study, right? Or if you wait for a bus, what's your bus wait time? So that's the point of study. And so we organize those results on the number line and visualize it. So it looks like number line is very straightforward, right? A line with a number on it. So what do you think? What kind of number you put there? Where you are going to put a 0, right? Start from 0. So we put it in the middle. So how about 0? What do you think? Right hand side, you will put a what? 1, 2, 3, 4, right? 1, 2, 3. Left hand side will be what? -1, -2. So the things on the left hand side will be negative. Things on the right hand side will be positive. So we are going to use the number line and put the points and find the distance, find the midpoint, right? And what kind of interval we go through and how we present them, okay? So look at your first one. There are many terminologies you are going to learn as well, okay? Vocabularies. So first one, the standard normal distribution is plotted above a number line. Just like, uniform distribution we plot on the number line like 12 to 58, right? Then this portion, we visualize it. We study all those 12 to 58, those numbers, then we visualize the result above the number line. We use the picture to show it, okay? So we study the line first. So you are going to have a number line, then later on you will have some kind of graph like this for your stats. Then we call it standard normal distribution. It's kind of normal, so it's like, what's that? Your COVID varies. It goes up to a point, it starts to die down. Things like that, okay? So, the most important value are the integer between -3 and 3. So we are interested in what? Between -3 and 3. The number 0 is both the mean and median. So you start to learn something called standard normal distribution. All right, you will learn that later. And you will learn also, you are learning what? Something called mean. You will connect the mean always with what? Average. Say average bus wait time, that will be the mean time, we call it. Another one is called median. What do you think? Median in the middle will be your center, okay? So it asks you to plot the number line that best displays this information, okay? -3 to 3, that's what we do. Then plot the value -1.45. What do you think? Negative on this side, 1.45 between 1 and 2, less than half, so it's about here, right? So you will plot this point, we call it point -1.45. That's how you plot the point. Point to the place we are going to care about. So that will be your x, okay, on your number line. So, next one, you are going to work with something called box plots later on. So, when working with box plots, we need to first set up a number line that labels what is called the 5-point summary, okay? So you are going to do minimum, first quartile, median, third quartile, and maximum. Suppose the 5-point summary for height in inches for a basketball team is 72, 74, 78, 83, 89. Plot those points on a number line. So our study is to do what? That's your x for your study, right? What is your x? For this one, we would be interested in what? The height for a basketball team. So x is talking about height. So height, the team can be by what? Inches. 72, 74, 78, 83, 89. So we want to plot those. So probably between 70 and 90. So I will have a 70 here, then mark 90, then I should have 80 around here. So that would be 75. That would be around 85, right? Then we want to point to the things we are studying regarding those basketball team's height. So one is a 7. So 5 points. We are more interested. The shortest one is what? 72. So you will mark 72. Another one is 74, right? 74. Another one is 78. You need to mark those points. And if another person is 83, another person is 89. So we mark those heights. All right, we are going to study on those. Then 5 points. So one is what? The shortest one is the minimum. The highest one will be what? Maximum, right? Then in the middle, see, 72 plus 89. So it's a median, okay? So we'll be care about. So we will care about what? 5 things when we study, okay? One is something called minimum, right? The last one will be what? Maximum, right? Then in the middle, we will call it median, right? Then quarter of it, we call first quartile. The third portion, we call it third quartile. You are going to figure out all those things later, right? We can figure out minima, median, maximum right now. So median is in the middle, center, right? Okay, so we just say plot those points on a number line. So those points are the concern we are going to study, see what kind of result will be. Okay, so we do the reference first. Reference points we care about. So look at the third one. Let's read the questions first. A 95% confidence interval, okay, for the proportion of Americans who work on the weekends is found to be 0.24 to 0.32, which with the center at 0.28. Use a number line to display this information. So you start to learn something called confidence interval. Okay, so 95%, you don't know what does that mean, but you will later, okay? But you start to get familiar, something called confidence interval, and with 90% of confidence you have, okay? For the portion of Americans who work on weekends, it's found to be 0.24 to 0.32. Okay, so with the center, use number line to show it. So you need to show what? 0.24 to 0.32. So it's about between 0.20 and 0.40, right? So that would be 0.30, that would be our 0.25, that would be 0.35. So we are going to mark the interval. Interval is the area we are concerning about is what? Between 0.24 and 0.32. So 0.24 is here. You mark it with a solid dot. So that's your 0.24. Another one is 0.32. It's right here, 0.32. We are talking about within that area interval. So you mark with a highlight, right? Mark the area. So that would be your interval. With the center at what? 0.28. So what is the center? Center is the middle, right? If you have $24, I have $32, what's our average? You will add them up. So that would be what? 56. Average would be what? Divided by 2, that would be $28, say. Right? So what's the median average in here? So what do? 0 to A plus real 3, 2, 0.32, 0.56, you divide by 2. So median would be what? 0.28. That's what they are talking about, right? Okay? So the interval notation, because it's an interval, we are going to learn interval notation as well. So from beginning to the end, so it's 0.04, so you put a comma, 0.32. Don't do this way, okay? Some of you will say, oh, I have 0.24, 0.28, and 0.32. You do that. We don't do that. Okay, interval notation means what? You write from beginning point to the ending point, which including everything in between. Everything in between. So that's called interval notation. Okay, for this interval. this portion. That's how we mark. So this line is what? Your X. X is talking about what? Confidence interval. So X represents the confidence interval. Then previous example, X represent what? The height of a basketball team. Okay? So that's the subject we are studying. Okay? Next one. Okay, for number 4, rejection region. We are going to learn a few terms. Okay, a few more terms. It says, in hypothesis testing, we sketch something called the rejection region, which is an interval that goes off to infinity or to negative infinity. Suppose that the mean number of hours to work on the week's homework is 4.2. The rejection region for the hypothesis test is all numbers larger than 7.3 hours. Plot the mean and sketch the rejection region on a number line. So many terms you are learning, okay? One is called what? Rejection region. And another thing you will learn is called something called hypothesis testing. You will do that later. Okay? Then it says, suppose the mean number of hours to work on the week's homework is 4.2. So if we graph a number line, okay, that's the study for your things, X. X is what? The number of hours, okay? So X is the hours or hours to work on your homework. Hours for homework, right? So this represents the idea for your homework. And so you want to mark what? 4.2, right? Also, the rejection region for the hypothesis test is all numbers larger than 7.3. So we also care about 7.3. They want you to plot the mean and sketch the rejection region. So mean is 4.2. So we need what? 0. So your study hour can be 0 hour, 1, 2, 3. You can study 4 hours per week, 5, 6, 7, 8, all that, right? Then let's see what are they talking about. One is 4.2. So you mark 4.2. It indicates what? Hours for homework is the mean number. So average, you mark, say, okay, this point is what? The average. Okay, for everybody in the class. Then it says the rejection region for the hypothesis test is all number larger than 7.3. So we find the 7.3, right? Larger than 7.3 can be 8 hours, 9 hours. So we are talking about this part to forever, right? So this part is what? It's called rejection region. So when you do the study, if you have this one, it's a rejection region. What do you mean by that? By rejection? It means anything, if you find a number, say this person, did the homework for 100 hours. Is that possible? If it belongs to rejection region, that means when we do the testing, we are going to reject that. Okay, something called rejection region for that area we are going to reject. For the X hours for homework bigger than 7.3, we are going to reject. If somebody studied 1.5 hour, then we study it. Okay, it's fine. Homework for 5.2 hours, that's fine. But the average is 4.2. That's the area we are concerning. It's from 0 to 7.3, but the average is 4.2. So we use that. Then can be negative. If go forever here, would be what? Infinity, we use this sign, right? This side is negative infinity. This side will be what? Positive infinity. So for this question, we learn a few terminologies. Something we will learn later on is called hypothesis testing. Then we think that you will have a rejection region. Then you will use the number line to refer to the things we care about at this moment we study for the hours for homework. Okay, so that would be your number 4. Okay, so we plot the number line, then we plot what? The point, then we plot what? The median, the center is the midpoint. We also learn a little bit about the interval notation as well. All right, then we do the distance. Look your page 26. All right, let's find some distance. It's pretty straightforward. Okay, distance between 2 points on a number line. The number line is the main visual base in stats, and we often want to look at 2 points on the number line and determine the distance between them. This is used to find the base of a rectangle or another figure that lies above the number line. Okay, so we are going to talk about distance between 2 points. Pretty straightforward. Okay, find the distance between 2.5 and 9.8. Okay, as shown on the number line. So you have 2.5 here, you have 9.8 here, 0 will be here, 10 will be there, right? So what's the distance? Distance will be what? You just find the difference. That will be the distance. Okay? Second one, when finding probabilities involving a uniform distribution, we have to find the base of a rectangle that lies on the number line. Find the base of a rectangle shown below, and that represents a uniform distribution from 2 to 9. Okay, so if here is 2, here is 9, you will have something called first quartile, median, third quartile, minimum, maximum, right? That's the number we work with. Then your base would be what? The base would be 9 minus 2. That would be your base. Then your height would be what? 1/7, right? 1/7 times 7 is 1. So that's how we do the base and graph it. Now we'll give you a rectangle for you to work with. Later on, you will do that yourself when it's needed, okay, in your stats class. Next one, number 3. The diagram below shows what? The confidence interval, something called confidence interval, right? You will use that later. And for the difference between the proportion of men who are planning on going into the healthcare profession and the proportion of women, what is the width of the confidence interval? What are they talking about? We are going to do some study, right? And talking about portion of the men and portion of women who are going to the healthcare profession, okay? But the reference is the X we are going to talk about, which is used for what? Confidence interval. Okay, that's the study. Then you say the study is what? Between, you marked here and marked here, negative 0.04 to, that's the confidence interval we are talking about. It's given to you like this. Then you say, what's the width of the interval? So what do you do the width? Find the distance, right? Would be 0.01 minus negative 0.04. So negative, you change it to positive. So you need to know how to handle the negative number. So that would be what? 0.05. That's all you need to do. Okay? So we are dealing with the things we are talking about, like this one talking about confidence interval. Then that's our x. So next one, if we give you a number line is here is negative 6358, here is negative 5215. It says the diagram here shows the confidence interval for the difference between the portion of the men who are planning on going into the healthcare profession and portion of the woman. What is width of the confidence interval? So confidence interval means what? Within this area, right? So what do? We do find the distance, minus negative 36358. So you do your math, become this, right? So you add them together and 1143. So you can use calculator to do it. Minus, but when you use a negative number, there is another, so on your calculator you have add, subtract, multiply, and divide, okay? But for the, if you minus negative, you don't do minus twice. Minus negative, there is another symbol on your calculator. It's for the negative. You need to take a look at that. And if you have questions, and you can go to tutoring center or call me, then we can go over with your calculator. Okay? Otherwise, you just Google it and search for the help for your calculator. You should get it as well. Okay, let's look at the next portion. We just did what? Midpoint. Not midpoint. Did we do midpoint? Not yet. We did distance. Okay, now let's do midpoint. Midpoint means what? In the middle. Right? Just like say, we said if you have $3, I have say $7. What's the average? What's the middle? Right? So you do total divided by 2. Then average will be $5. Right? So if we are given two numbers, look at your page 27 on the top. If we are given two numbers, then the midpoint is just the average of two numbers. To calculate the midpoint, we add them up, then divide the result by 2. The formula is what? The midpoint will be what? Starting point, ending point, divided by 2. That's your formula, right? Let's look at some examples. Find the midpoint of number 3.5 and 7.2. So what do? You just do beginning the number plus end the number and divided by 2. Then you use calculator. So if you use calculator directly, you can add it together, become 10.7, then you divide by 2. You get an average midpoint, right? If you use calculator directly, what do? You do this, divided by 2, you get a wrong answer because the calculator will follow order of operation, so that would be 3.6 and number 7.1. So you need to do what? We say this line means what? A group symbol. So if you put into the calculator, you need to put a parenthesis there for it, right? Very straightforward, this section. So let's look at the next one. Sketch the point -3, 5, and the midpoint for these two numbers on the number line. So you need a what? -3, you need a 5. So you mark those, right? Then midpoint. Midpoint is what? Would be -3 plus 5 divided by 2. -3 plus 5 is 2. 2 divided by 2 is what? 1. So the middle point should be 1. Is that right? So, right. Okay. Next one. A major topic in statistics is the confidence interval. You will use confidence interval a lot, which tell us the most likely interval that the mean or the proportion will lie in. Often the lower and the upper bound of the confidence interval are given, but the midpoint of these two numbers is the best guess for what we are looking for. Suppose a 95% confidence interval for the difference between two means is -1.34 and 2.74. Find the midpoint of these two numbers, which is best guess for the difference between the two means. So we are going to talk about something related to confidence interval, right? And the difference between -0.14 and 2.79 is our study. Okay, and find the midpoint. Midpoint is what? You just add them up. 1.34 plus 2.79, then you divide it by 2, right? So we should have 1.34 plus 2.79, put a parenthesis, divided by 2. So your answer should be, if you use calculator, you should get this answer, right? Midpoint, you just follow the formula, a plus b divided by 2, right? So that's your formula. Next one, we are going to do hypothesis testing again. Okay, something called hypothesis testing. Another application of the midpoint involves hypothesis testing. Sometimes we are given the hypothesized mean, which is the midpoint. We guess what's in the middle. We are also given the sample mean, okay, which is either the left or right endpoint. The goal is to find the other endpoint. Suppose that the midpoint hypothesized mean is 3.8 and right endpoint is at 5.1. Find the value of left endpoint. Okay? So later on you will learn we are going to use hypothesis testing, and you will have what? Something called hypothesis mean, hypothesized mean. Okay, that means you guess what's the average, right? It says 3.8. Then when you collect the data, it's actual, your samples. Then you have a sample mean here. On the right hand side, sample mean is what? 5.1 on the right hand side. Then what is the left hand side of the sample mean? Okay, sample mean. Hypothesized mean is what? in between the data you collect, right? Sometimes average bunch sample, you got a 5.1, but sometimes you got less. But average out, you got a 3.2 according to the way you hypothesized. Okay, so we want you to find this point. How should we do? Right? This is in the middle. That means they have same distance to both sides. Right? So what's the distance? 5.1 minus 3.8. You should get what? 1.3. So 1.3 here. Here, more or less, from the middle, 1.3 more or 1.3 less. Right? So this side is less. That would be 3.8 minus 1.3. That would be 2.5. So your left-hand side should have sample mean of 2.5. That's how we will apply those number line points, right? Distance, midpoint, and interval. Okay? So it's just a basic concepts for the things we are studying, use X for. Okay? So that will cover your section 3.1, 3.2, and 3.3.